Hi everyone, Cody D'Amico, and welcome to my presentation on agricultural data collection and livestock hydration monitoring using open source Internet of Things hardware. In this presentation, you'll see my introduction, scholarly literature review, my research objectives, methods, architecture, and approach, my prototype testing, the expected results, and conclusions and future opportunities. The changes in technology over the years related to farming is pretty amazing. Going from hunters and gatherers to fully autonomous GPS guided tractors today, it's pretty incredible the changes in efficiency that you can see. In the center of my slide here, you can see 1830, it took between 250 and 300 labor hours to produce 100 bushels of corn on 4 acres of land. Fast forward to today, that same 100 bushels only takes about 2.75 labor hours and just over half an acre of land. With urban sprawl and the cost of land increasing, farms have continued to get smaller, yet using today's technology, they're able to produce more than ever with a significantly higher yield per acre. When people think of Industry 4.0, the first thing that comes to mind is not farming. It's typically large industrial manufacturing plants, but something that's really cool is this new trend of precision livestock farming. By utilizing smart tracking with wearables and environmental sensors, today's farms can gather the same important data similar to those large industrial plants, except related to their animals, and they can track their animals' welfare and even help detect early signs of disease. Some motivation for this project, I grew up on a small farm outside the city. I think it would be awesome to continue making change and improving the agricultural industry. By combining interactive sensing systems with farming, the open source community can help bring these advanced technologies. In the farming world, they're typically held behind expensive paywalls to the hardworking farmers. In my background research into precision agriculture, I found that there was a much larger focus on crop tracking than livestock tracking. Most of the livestock offerings that were out there included identification monitoring, health metrics monitoring with wearables for temperature, heart rate, blood pressure, breeding, and then GPS location monitoring for grazing management and disease exposure tracking. I identified a gap in food or water intake tracking where water intake is especially important in something like dairy cattle, as it can have a direct impact on the quality and quantity of milk produced, not to mention the health risks of dehydration. And this is just a list of the articles that I used when creating my report, if anyone's interested in checking them out. For the research objectives of my project, I'm looking to identify potential use cases for microcontroller-based data tracking for precision livestock farming. In this case, specifically an Arduino-based hydration monitoring system for livestock. By recording the water intake, farmers can easily review trends and anomalies in data that may allow for early identification of health concerns. And by bringing new open source hardware and software for livestock management, we can help those farmers support sustainability and enable them to adopt low cost, open source data tracking and traceability that can bring efficiency improvement. Under methods, architecture, and approach, this is the hardware that I'm going to use in my prototype. I've got an Arduino Uno R4, passive infrared motion sensor, got an RFID sensor, tokens, I've got a water flow sensor, a DHT22 temp and humidity sensor, my local area network, and an LCD display, 4 rows and 20 columns. Under methods, architecture, and approach, I've got my concept of operation. Step 1, initialize your Arduino. The motion sensor is going to begin recording, looking for motion. Once it's detected, the RFID sensor is going to start reading, looking for RFID tags that correlate with specific animals. Once an RFID tag is detected, it's going to start looking at the water flow sensor, indicating that the animal is drinking. Once that stops, it's going to take that data. Also, it's going to record temp and humidity. It's going to calculate the volume of water consumed, and it's going to record all of the data onto a network location. And then the LCD screen is going to report, hey, you had a successful reading, or hey, you had an error. On this slide, I've got system activity diagram. Once again, we're looking at motion and then RFID, and then we're going to start monitoring water flow. Once the water flow stops, we're going to say, hey, is that RFID still in the area? If yes, keep monitoring water flow. If no, record that water flow data to the network location, and then check temp and humidity and record that to the network location, and then update the LCD with success or failure or standby. I've got a couple loops back to standby for checking temp and humidity at set intervals. Although this is geared towards agricultural livestock with the duration of the semester, I've got to scale this down a little bit. My initial design is going to be adapted to a small scale prototype used for monitoring hydration of household pets. However, it is going to be fully featured as intended for livestock. Current plan is to build a tank-fed water bowl that I can use with my two dogs. Pictured on the right, you've got Bailey, the Basset Hound, and Bella, the Blue Heeler. In terms of expected results, I'm looking for the water ingestion data per animal with the date and time stored as a CSV file that I'll be able to pull into Excel, build graphs and check for trends. Data collected will be compared to the environmental factors of temp and humidity at those same times to detect potential anomalies that could signal health concerns. In conclusion, my research is investigating the use of Arduino-based systems for tracking hydration in livestock using RFID with water flow sensors to monitor water consumption compared to environmental conditions. By continuing to incorporate interactive sensing systems with agriculture, farmers can follow the Industry 4.0 trend and continue to increase their efficiency and throughput while reducing man hours. Some future opportunities could include modifying the system to include monitoring of additional metrics, maybe combining it with an existing sensing system, or even reconfiguring it into a smaller package. Thanks for watching my presentation.